An amplifier, electronic amplifier or amp is an electronic device that can increase the power of a signal. It does this by taking energy from a power supply and controlling the output to match the input signal shape but with a larger amplitude. In this sense, an amplifier modulates the output of the power supply to make the output signal stronger than the input signal. An amplifier is effectively the opposite of an attenuator. While an amplifier provides gain, an attenuator provides loss. An amplifier can either be a separate piece of equipment or an electrical circuit within another device. The ability to amplify is fundamental to modern electronics, and amplifiers are widely used in almost all electronic equipment. The types of amplifiers can be categorized in different ways. One is by the frequency of the electronic signal being amplified. Audio amplifiers amplify signals in the audio range of less than 20 kHz. RF amplifiers amplify frequencies in the radio frequency range between 20 kHz and 300 GHz. Another is which quantity, voltage or current is being amplified. Amplifiers can be divided into voltage amplifiers, current amplifiers, transconductance amplifiers, and transresistance amplifiers. A further distinction is whether the output is a linear or non-linear representation of the input. Amplifiers can also be categorized by their physical placement in the signal chain. The first practical electronic device that could amplify was the audio vacuum tube, invented in 1906 by Leda Forrest, which led to the first amplifiers. The terms amplifier and amplification were first used for this new capability around 1915 when triodes became widespread. For the next 50 years, vacuum tubes were the only devices that could amplify. All amplifiers used them until the 1960s, when transistors appeared. Most amplifiers today use transistors, though tube amplifiers are still produced. Figures of merit. Amplifier quality is characterized by a list of specifications that include gain, the ratio between the magnitude of output and input signals; bandwidth, the width of the useful frequency range; efficiency, the ratio between the power of the output and total power consumption; linearity, the degree of proportionality between input and output; noise, a measure of undesired noise mixed into the output; output dynamic range, the ratio of the largest and the smallest useful output levels; slew rate, the maximum rate of change of the output; rise time, settling time, ringing and overshoot that characterize the step response; stability, the ability to avoid self-oscillation. Amplifier types. Amplifiers are described according to their input and output properties. They exhibit the property of gain, or multiplication factor that relates the magnitude of the output signal to the input signal. The gain may be specified as the ratio of output voltage to input voltage, output power to input power, or some combination of current, voltage, and power. In many cases, with input and output in the same unit, gain is unitless. The four basic types of amplifiers are as follows. Voltage amplifier. This is the most common type of amplifier. An input voltage is amplified to a larger output voltage. The amplifier's input impedance is high and the output impedance is low. Current amplifier. This amplifier changes an input current to a larger output current. The amplifier's input impedance is low and the output impedance is high. Transconductance amplifier. This amplifier responds to a changing input voltage by delivering a related changing output current. Transresistance amplifier. This amplifier responds to a changing input current by delivering a related changing output voltage. Other names for the device are transimpedance amplifier and current-to-voltage converter. In practice, amplifier power gain depends on the source and load impedances, as well as the inherent voltage and current gain. A radio frequency amplifier design typically optimizes impedances for power transfer, while audio and instrumentation amplifier designs normally optimize input and output impedance for least loading and highest signal intensity. integrity. An amplifier that is said to have a gain of 20 decibels might have a voltage gain of 10 times and an available power gain of much more than 20 decibels, yet actually deliver a much lower power gain if, for example, the input is from a 600 ohm microphone and the output connects to a 47 kilo-ohm input socket for a power amplifier. In most cases, an amplifier is linear. That is, it provides constant gain for any normal input level and output signal. If the gain is not linear, e.g., clipping of the signal, the output signal distorts. There are, however, cases where variable gain is useful. Certain signal processing applications use exponential gain amplifiers. Many different electronic amplifier types exist that are specific to areas such as radio and television transmitters and receivers, high-fidelity stereo equipment, microcomputers and other digital equipment, and guitar and other instrument amplifiers. Essential components include active devices, such as vacuum tubes or transistors. A brief introduction to the many types of electronic amplifiers follows. Power amplifier. The term power amplifier is a relative term with respect to the amount of power delivered to the load-in, or provided by the power supply circuit. In general, the power amplifier is the last amplifier, or actual circuit in a signal chain and is the amplifier stage that requires attention to power efficiency. Efficiency considerations lead to the various classes of power amplifier based on the biasing of the output transistors or tubes. See power amplifier classes. Power amplifiers by application. Audio power amplifiers. Speakers allows client to use both sides to maximize volume, but each side receives half of what it could potentially supply. RF power amplifier, typical in transmitter final stages. Servo motor controllers. Amplifier control voltage where linearity is not important. Piezoelectric audio amplifier includes a DC to DC converter to generate the high voltage output required to drive piezoelectric speakers. Power amplifier circuits. Power amplifier circuits include the following types: vacuum tube, valve, hybrid or transistor power amplifiers, push-pull output or single-ended output stages. Vacuum tube amplifiers. According to Simmons, while semiconductor amplifiers have largely displaced valve amplifiers for low-power applications, valve amplifiers are much more cost-effective in high-power applications such as radar, countermeasures equipment, or communications equipment. Many microwave amplifiers are specially designed valves, such as the Klystron, gyrotron, traveling wave tube, and cross-field amplifier, and these microwave valves provide much greater single-device power output at microwave frequencies than solid-state devices. Valves, tube amplifiers also have following uses in other areas, such as electric guitar amplification, in Russian military aircraft for their electromagnetic pulse tolerance, niche audio for their sound qualities. Transistor amplifiers. The essential role of this active element is to magnify an input signal to yield a significantly larger output signal. The amount of magnification is determined by the external circuit design as well as the active device. Many common active devices in transistor amplifiers are bipolar junction transistors and metal oxide semiconductor field effect transistors. Applications are numerous. Some common examples are audio amplifiers in a home stereo or power system, RF high power generation for semiconductor equipment, to RF and microwave applications such as radio transmitters. Transistor-based amplifier can be realized using various configurations. For example, with the bipolar junction transistor we can realize common base, common collector or common emitter amplifier. Using a MOSFET we can realize common gate, common source or common drain amplifier. Each configuration has different characteristic. Magnetic amplifiers. These are devices somewhat similar to a transformer where one winding is used to control the saturation of a magnetic coil, hence alter the impedance of the other winding. They have largely fallen out of use due to development in semiconductor amplifiers but are still useful in HVDC control, and in nuclear power control circuitry to their not being affected by radioactivity. Operational amplifiers. An operational amplifier is an amplifier circuit with very high open-loop gain and differential inputs that employs external feedback to control its transfer function, or gain. Though the term today commonly applies to integrated circuits, the original operational amplifier design used valves, and later designs used discrete transistor circuits. Fully differential amplifiers. A fully differential amplifier is a solid-state integrated circuit amplifier that uses external feedback to control its transfer function or gain. It is similar to the operational amplifier, but also has differential output pins. These are usually constructed using BJTs or FETs. Video amplifiers. These deal with video signals and have varying bandwidths depending on whether the video signal is for SDTV, EDTV, HDTV 720p or 1080p, etc. The specification of the bandwidth itself depends on what kind of filter is used, and at which point the bandwidth is measured. Certain requirements for step response and overshoot are necessary for an acceptable TV image. Oscilloscope vertical amplifiers. These deal with video signals that drive an oscilloscope display tube, and can have bandwidths of about 500 MHz. The specifications on step response, rise time, overshoot, and aberrations can make designing these amplifiers difficult. One of the pioneers in high-bandwidth vertical amplifiers was the Tektronix company. Distributed amplifiers. These use transmission lines to temporarily split the signal and amplify each portion separately to achieve higher bandwidth than possible from a single amplifier. The outputs of each stage are combined in the output transmission line. This type of amplifier was commonly used on oscilloscopes as the final vertical amplifier. The transmission lines were often housed inside the display tube glass envelope. Switched mode amplifiers. These nonlinear amplifiers have much higher efficiencies than linear amps, and are used where the power saving justifies the extra complexity. Negative resistance devices. Negative resistances can be used as amplifiers, such as the tunnel diode amplifier. Microwave amplifiers. Traveling wave tube amplifiers. Traveling wave tube amplifiers are used for high power amplification at low microwave frequencies. They typically can amplify across a broad spectrum of frequencies, however, they are usually not as tunable as Klystrons. Klystrons are specialized linear beam vacuum devices, designed to provide high-power, widely tunable amplification of millimeter and sub-millimeter waves. Klystrons are designed for large-scale operations and despite having a narrower bandwidth than TWTAs, they have the advantage of coherently amplifying a reference signal so its output may be precisely controlled in amplitude, frequency and phase. Musical instrument amplifiers. An audio power amplifier is usually used to amplify signals such as music or speech. In the mid-1960s, amplifiers began to gain popularity because of its relatively low price and guitars being the most popular instruments as well. Several factors are especially important in the selection of musical instrument amplifiers and other audio amplifiers. Frequency response, not just the frequency range but the requirement that the signal level varies so little across the audible frequency range that the human ear notices no variation. A typical specification for audio amplifiers may be 20 Hz to 20 kHz plus or minus 0.5 decibels. Power output, the power level obtainable with little distortion, to obtain a sufficiently loud sound pressure level from the loudspeakers. Low distortion, all amplifiers and transducers distort to some extent. They cannot be perfectly linear, but aim to pass signals without affecting the harmonic content of the sound more than the human ear can tolerate. That tolerance of distortion, and indeed the possibility that some warmth or second harmonic distortion improves the musicality of the sound, are subjects of great debate. Before coming onto the music scene, amplifiers were heavily used in cinema. In the premiere of Noah's Ark in 1929, the movie's director used the amplifier for a festival following the movie's premiere.